Hello, Kaylee, Michaela, and William. This video is to catch you up on the portion of class from Monday, March 6th on fact fluency. I wanted to tell all of you guys, if possible, come about, 15 minutes early to class, Monday the 13th, I believe, so that you can make up the content quiz that we took on March 6th. We took it in the middle of class, okay? So come early so you can make that up. Let's get into fact strategies, which was part of our portion of class, let's say about the last hour of class on Monday. And we are going to begin by doing a lesson on a fact strategy that you guys have probably read about in your progression, in your standards, and in your Van de Waal text. And the strategy is make a 10. And it's a powerful fact strategy as illustrated in your Van de Waal text. It not only works with some smaller problems like single digit and single digit, but it also works when you get into work with larger numbers. We can use it because it's based on place value and getting to that next decade, so getting to that next multiple of 10 or even within 1,000, so getting to that next 100. But this starts in first grade, sometimes late kindergarten, and it's a powerful one. And so we're going to walk through a lesson about how to do this with kids, starting with concrete and moving to more complex, sophisticated ways of practicing this strategy. So here we go. So these three problems on the screen are 10 and some more facts. Okay, and this would be a prerequisite before introducing the Make a 10 strategy. Your kids would need to be fluent with adding any single digit number to 10. So I have 10 and 4, 10 and 7, 10 and 8. We would quickly just give the sum of each of these problems, and then I would ask kids, man, you are so quick at solving those. Why are those so easy for us to solve? And I would let the kids answer that question and give me some ideas about what makes those so easy. And so you guys can think about things that kids might say. And in class, we had the students think about what would kids say. And they said, well, you're just taking the other number and putting it where the 0 is in the tens because you're just adding some ones to your 10, and they mentioned some different things. But again, this is a prerequisite. Kids got to be able to do this before you would do Make a 10 strategy. So the next thing you would tell students is that we're going to look at some problems that are a little bit harder to solve. They're not as easy as our 10 and some more, but we're going to see if we can use the 10 and some more to make some harder problems easier for us to solve. So get out your double 10 frame, and you have a copy of this on cardstock, I believe. Looks just like the one on the screen. And get yourself some counters, so some coins or beans or, pasta, macaroni shells, anything that you can have about 20 of. And what I need you to do is build 8 on the top 10 frame, 5 on the bottom 10 frame. If you're not familiar with how to use 10 frames, we build our quantities left to right, top to bottom, just like we read. So build your 8, build your 5, and then check yours. Check your representation with mine. That's how the 8 is built, left to right, top to bottom. And then build your 5. So right now we have a 10 frame representation that matches our problem at the top of the screen, 8 plus 5. My question at this time to kids is, without adding into any counters to our 10 frame that we have, is there a way to fill the top 10 frame so it is filled with all 10 counters? But you can't add any more counters to our 10 frames. So I asked the kids this question, and I have them talk about it first before they actually do it, but you're going to have a kid in the class and hopefully multiple kids in the class that are like, yeah, you can move 2 from the bottom 10 frame up to the top 10 frame. Okay, everyone, let's do that. So right now, move your 2 from the bottom 10 frame up to the top 10 frame. Just like that. Now, the problem at the top of the screen is 8 plus 5. However, if you look at our 10 frame representation, it does not match the problem at the top of the screen. It no longer shows 8 and 5. It shows 10 and 3. We just changed 8 plus 5 into a 10 and some more fact. Boys and girls, what's 10 and 3? And of course, all of them would answer 13. Okay, so you will have kids that will need to do this repeatedly. They will need to do this physical movement of building the two add-ins and then physically moving part of the quantity to fill that top 10 frame. Or maybe you move some from the top to fill a bottom 10 frame if your second add-in is the larger add-in. It just depends on your problem. But you'll have kids that need to physically move it repeatedly. They need to practice at this stage, at this very early concrete stage of making 10 for a while. But eventually, you want kids to be posed with another problem, such as 7 and 4. And on this one, I just have our 10 frame flashcards that you could use where it's not actually built, although you could have kids build it. So we would build 7 and we would build 4, or we'd pull out our 7 10 frame card and our 4 10 frame card. And this time, instead of physically moving them, I would ask kids, can they move them in their mind? And they think it's like a magic trick. So right now we have 7 and we have 4. Can you move some counters in your mind so that our top 10 frame has all 10 spaces filled? And so you have kids that say, yeah, I can move it in my mind. I would move 3 from the bottom to the top to fill up my top 10 frame. So then I would ask kids, oh, okay, that's an idea. We could. So what would our new problem be? Because it wouldn't be 7 and 4 anymore. And you have kids that are thinking about this in their mind, visualizing it, and able to tell you, oh, it would be 10 plus 1 instead. So this is the next stage of using the Make a 10 strategy with kids. We went from building it with the physical model, moving it, actually moving the chips, physically moving them from the bottom to the top to fill the top 10 frame, to just showing them the visual quantities on 10 frames and asking them, could you move the quantities in your mind? Because eventually we want them to have that mental math fluency and able to do it just in their mind. So this is like the second stage of using this strategy and practicing it with kids. Eventually you also want to get to the use of a Rec and Rec, which you have a Rec and Rec as part of your class supplies from last night. That's yours to keep forever. So this is a tool that's very commonly used in our K2 classrooms, and obviously this tool just has 2 rows of 10 beads, but we use number racks that have like 10 rows of 10 beads, so for fluency within 100. But this is a common one used in our K1 classrooms and even in our 2nd grade classrooms. So take your Rec and Rec, and I would like you to build on your Rec and Rec 9 plus 3. So you're going to move 9 beads over to the left on the top line, and then on the bottom row, move 3 over. So it'll look just like mine, 9 and 3. Now with this tool, it's a little bit different, but we can do the same thing. I would ask kids, okay, so how could we use our Rec and Rec to change 9 and 3 into a 10 fact, so a 10 and some more. And you would have kids, as you guys can predict, that would say, oh, we could move that last bead over on top to have a full 10, but that means we'd have to take one away from the bottom. This is a really important idea called compensation, and it is a very important idea that helps kids with algebra concepts later on. Okay, so whatever you do to one add-in, you have to do the opposite operation to the other add-in because you want your whole quantity to remain the same. So we would actually physically move that white bead, so we have 10 on top, and you would remove a red bead from the bottom row, and so your new equation would be what? It would be 10 plus 2. Which is such an easy problem for us to solve because our 10 and some mores are so easy, and it would be 12. Now, question I asked the kids in class on Monday. Why is using the Rec and Rec and manipulating a Rec and Rec more complex than how we started with physically moving the chips on the 10 frame? And so we discussed that, well, you're not actually able to take that bottom bead, that 3rd bead on the bottom of the Rec and Rec. You can't move that red bead from the bottom row to the top row. You actually are compensating, and you're adding one to the top and you're taking one away from the bottom. But again, the one you're taking away from the bottom isn't getting to go to the top. It's represented with a different bead. So on the 10 frame, we physically moved the chips from the bottom 10 frame to the empty spaces on the top 10 frame, which is the most concrete level. So this is a little more sophisticated, but we want to get kids to this level because it's really, really important for truly understanding compensation. And this is a great tool to do that with. And then lastly, we just use some like typical flashcards, as you can see on the screen, that lend themselves to building that 10 and then counting on from there. And we just paired up, showed a partner the fact on the card, and they didn't tell us the sum. They had to tell us the 10 and some more fact. So they had to use the make a 10 strategy. So if I saw 9 plus 3, my job would be to change it into a 10 and some more fact, which would be 10 and 2. And then we just traded and switched roles with our partners doing that. We talked about most conceptual to most abstract. So looking at our physical models we did with the 10 frames, then using the 10 frames still, but moving it in our mind, not physically moving it. Of course, the use of the rec and rec for compensation. And then finally, eventually we want kids to just be able to look at the problem, use that strategy mentally, and use it efficiently to solve some simple addition facts. This lesson comes from the book Addition and Subtraction Fact Strategies, which you guys have with you, and I think it has a pink cover. It's not the green cover that you see on the screen, but it is a pink cover. And if you turn to page 58 in this book, that is the Make a 10 lesson in this book that I just did with you, and I literally pretty much did it verbatim. I would like for you can look at that, and you can pause this and take a look at that lesson if you want. When you turn the video back on, if you would please turn to page 45. So I want to show you another lesson in this book. So on page 45 in your Addition, Subtraction, Fact Strategies book, this portion of the book is dedicated to the doubles plus 1 fact strategy. So those near doubles. And so every fact strategy, most of the time, almost everyone, the lesson, when it says teaching the fact strategy, it's going to start with a problem in context, which we know is so important to do contextual-based problems to get to procedural fluency. Okay, so it always starts with a context problem that you would lead the kids through and have them solve and get their strategies, and hopefully you have someone share the doubles plus 1 strategy. And then if you turn the page, you'll see there's a teaching the fact activity outlined for you, but then you can see in the rectangles for doubles plus 1 fact strategies, there are 3 different practice activities, games, things the kids can do to practice that particular strategy, which is really important. If they're going to truly develop and own a strategy, they have to be given ample time to practice the strategy. This slide just shows in this book how the strategies are sequenced. It starts with counting on, goes to facts with 0, to doubles, doubles plus 1, combinations of 10, make a 10. All of them have full lessons outlined in this book, and this is a resource for you. You could definitely get some ideas from here for your Operations and Algebraic Thinking lesson plan that is due next week. I am going to stop this video now, and our next video is going to start with what we did with this article, 3 steps to mastering multiplication facts. So you'll need the next video link for this next portion.